Very good morning, students. So welcome to IIT NEET or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 9 students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 9th. Our ongoing chapter, Basic Math in Physics. Basic Math in Physics. Today we are entering into the session number 4. So how come the mathematics help in understanding the concepts of physics? That's all you want to know about this. It looks like mathematics class, but it's not a mathematics class. It is a physics class, right? So already in last 3 sessions, we discussed about a few important chapters which helps us to understand the concept of maths, physics, or which are mathematics, which can be helpful in solving the physics numericals. Like that trigonometry, basically we start with algebra, all the formulas of algebra, then trigonometry, trigonometric functions, rules of the trigonometric ratios, and many more about the trigonometry. We're done with algebra and trigonometry. These are the 2 important chapters where we have the help with which are helps in the physics, right? So once again, I'm telling, remember, it is a physics class, not mathematics class. Just the way we'll just glance. We'll glance into the chapter and move to the next instead of going in deep, right? We are not going in deep about the chapters, only we have to remember the rules and formulas of the okay. So next, after knowing about the trigonometry, these are the trigonometry things which we already seen. You need to practice that levels. Now next part is differentiation. Another important mathematical concept which is helpful in physics is differentiation. The word itself indicates, see, the purpose of differentiation is to study the nature of quantity that is increasing or decreasing. Whether any quantity is either increasing or decreasing can be understood by differentiating. How can you say that you are a good student when some more students are there? A student getting first rank is a good student because he is compared with the other 25 or 30 students. A hotel is the number 1 hotel because it is differentiated with the other hotels. A person is a humble person when compared to other persons. We cannot say Modi is the best PM in the world. It is possible when you compare him with the other country PMs. There should be a comparison. Whether comparison there is a decreasing or increasing, no matter. Okay. And the amount of variation, how much difference is there? Rating. For example, you got 5 rating. Some other got 4.5. That also there, difference. We can differentiate them. Right? That is the importance of differentiation, which is also helpful in the physics. Whether the nature of quantity is increasing or decreasing. If increases, how much increases? If decreases, how much decreases? That is the right? Understood? That is called variation. When other quantity on which first quantity depends varies independently. So for example, there is A is there, B is there, C is there. So when you compare these two, A is the number 1, B is number 2. When you compare same A with the C is number 1, A is number 2. It's not compulsory that A is always number 1. Simple example, you are top ranker in the class, first ranker. But when you have 2 sections, A and B sections, you are A section student, topper of A section. In B section, there is one topper is there. But when you compare the toppers, B section maybe the more got more marks than you. Means that is here. When another quantity on which first quantity depends on the various independently. This is simply comparing only here. Differentiation is nothing but comparing whether increasing or decreasing. If increases, how much decreases? If increases, how much increases? Not only that, that depends on the quantities also. Right? That is called differentiation, which is having its own formulas and all. How to compare? You can see here the next. For example, see average change. We know there is a change is there. There is a change, but how much the change is there? How much change is there? Called comes under average. Okay. So average rate of change. What is the rate? Is nothing but time. Let function y is equal to f into f of x. You can call it as f of x. Right? Plotted as shown in the figure. Here plot is done in the graph paper. Average rate of change in y with respect to x is x1, x2, x1, x2, and what is? They are called coordinates. So then average rate of change is nothing but change in y by change in x. That is y2 minus y1 by x2 minus x1. So x and y are the coordinates here. So what is change? Final minus initial. Average change, you can call it delta also represented, or simply y2 minus y1. So you get the what is AB value. So whenever A and B are points on a coordinate whose coordinates are given by x1, x2, y1, y2, then average rate of change is given by y2 minus y1 by x2 minus x1. Right? So by that you can find out what is the slope called AB by using that formula. Okay. Then next part is instantaneous. Instantaneous at any time. Instantaneous means at any time. You want to find out at any time what is the speed. Suppose you are going by two-wheeler. If somebody called you and asked what which speed you are going there, immediately you can tell because there is a speedometer, which clearly indicates the how much speed you are going. Either 40, 50, 60, 70, 80, right? That is called instantaneous. It is defined as rate of change of y with respect to particular value of x, particular value, not overall. Overall means you can say y2 minus y1 by x2 minus x1. Okay. So it is measured graphically by slope of tangent. By slope, we can find out this. Suppose y is equal to x like previous given. Instantaneous rate of change is nothing but dy by dx. So dy by dx will call. We can find out the differentiation of y with the differentiation of x. The d indicate differentiation. So that is nothing but slope. That is tan theta value had calculated. We get the tan theta is equal to dy by dx. So already know what is tan theta. Opposite side by hypotenuse. So there are some rules are there for the derivatives. When you want to use the derivative, this is called derivation. Derivative. Some rules are there, you can see here. So derivatives of various constants and variables. We can see that is very important in the differentiation. Okay. So what is the rule number one? Rule, not rule number. So rule number one says that derivative of constant is 0. We take any constant 1, 2, 3, 4. So d by dx in place of y, suppose there is 2 is there. D by dx is equal to 0. Any constant, the differentiation of any constant is always taken as 0. Okay, then. So example is given. In the room, at any point, if temperature is constant, then d theta by dx, the temperature, room temperature. Theta T is nothing but temperature. Differentiation of temperature in a particular room is always 0 only. Then second example is given. In a room at a given place, temperature is constant throughout the day. Throughout the day also it's taken as 0 only. So what is the differentiation of room temperature? d by dt is equal to 0. At a particular time also 0 only. Throughout the day also 0 only. Means the derivative of the temperature in room is always 0. or constant is 0. That is rule number 1. The second rule, power rule. That is called power rule. D by dx, x power n. Whenever any, for example, x square is given. In place of n, anything you can take. So d by dx, the derivative of x power n, that is power is given by, how can you see n power is there, na? N will come down, base, nx, n minus 1. Right. So d by dx of x to the power of n is given by, so x square and now, for example, we will get 2x 2 minus 1. That is 2x1 or 2x. In case of it is x square. So this is the formula. 2 by dx of any power. D by dx of any power is given by nx n minus 1. Means n, the power will come this side and power minus will come in the denominator. Like that, for anything you can write. For any powers, you can write this is applicable. Formula is applicable. See, y is equal to x to the power of n we have taken. Then dy is equal to, that is derivative of y is equal to nx n minus 1 dx. Dx will come here. No? That is the second rule. In case that is called power rule. Power rule. When the power is there, how to get the derivative or differentiation. Okay. Then rule number 3. Constant multiple rule. Constant multiple. First is constant. Second one is power. Third one is constant multiple rule. So here, two constants are multiplied. So what is the y value here? Y is equal to ax to the power of n. So both are constants only. Then how to write it? A will come before, that is d by dx, a d by dx of x power n, you can write it. We know how to write the x power n. A is a constant, a, x power n is nothing but n x power n minus 1. That is second rule we applied here, power rule. A is the constant as it is. Correct or not? So this is the derivative of a x power n. A as it is, x power n is written as nx n minus 1. That is the third rule called constant multiple rule. So for constant, always 0. For power, we have seen. And constant multiple rule is this third one. Rule number 3. Rule number 3. Rule number, not rule number. Then fourth one, sum rule. Sum is addition. Sum is given. See, sum is sum rule. So d by dx means value is a sum here. U plus v. When sum of the numbers are there, how to write the derivative of y? See here. We can write du by dx, separately we written, plus dv by dx. Du by dx plus dv by dx. Separately you can just like a plus b into a, how to write 2 into a plus b is there, for example. What do you write here? 2a plus 2b. Same here also. When sum is there, we can write separate differentiation. And later you can apply either power formula or constant formula or constant constant multiple formula, no matter. So one is multiple formula, one is now sum formula. How to write the derivative of the sum? Simple way. Clear? That is rule 4. Rule 5, product. Sum is over, constant multiple is over, power rule is over, constant is over. Now it is product rule. Product is no multiplication. So d by dx of uv, u into v. Here then u minus u plus v, wrote uv, multiple. When there is a multiples are there, multiplication is there. What we have to see here? The formula. So v into du by dx plus u into dv by dx. That's all. Simple way. Applying the when there is a multiple derivative is there, derivative of multiples is given like this. First v into du by dx plus u dv by dx. That is derivative rule 5. So all you need to practice, you need to remember, so that is helpful for you in the higher classes, even in the IIT also. So rule number, it looks very tough, but if you remember the rules, if you learn the rules, it becomes easy and you can write the derivative of anything. Coefficient rule. Coefficient, there is a coefficient, is there? What is the rule? See here. So d by dx of u by v. That is when there is a division. Addition, multiplication, division. All key. So how to write this? For this you can write. This is the answer. V du by dx minus u dv by de by v square. That is the derivative of the coefficient rule. Very important. Right? Sixth one. Then comes 7. Rule 7. Derivative of trigonometric functions. Very interesting. Derivative of sin x is cos x. Cos x is minus sin x. Tan x is secant square x. The fixed rule number 7. For first 3 functions, it is as y, if y is equal to sin x, then derivative of sin x is cos x. Derivative of cos x is minus sin x. Whereas derivative of sin x, tan x is secant square x. Right? Very important for the derivatives of trigonometric functions. When you come for 8th one, derivative of logarithm functions. You might have learned logarithms in the maybe in 8th or 9th or we are getting. So this is the formulas for the logarithm functions or derivatives of logarithm functions. There are so many are given A, B, C, D. Logarithms in the various forms. So y is equal to, if it is nx, dy by dx is equal to 1 by x. So y value is given. What is the differential derivative? 1 by x. Log ax, log base ax is given. So answer is. So these are the formulas, the rules to remember. Chain rule also given. Chain rule or outside rule. dy by dx is equal to dy by du, du by dx. So these will come across in general in high classes, right? And finally, that rule number 10. So these are the 10 rules which satisfies the derivative of all 4 our addition, subtraction, multiplication, and division also. Operations, mathematical operations. So there are 10 rules are there. You have to remember this. These are the simple formulas. So I'm not telling anything new here. I'm just telling about the formulas of mathematics which are connected to our physics. Okay. So there are some double derivatives also possible. Not only one derivative. There's a possibility of getting double derivatives in higher classes. Right? That will come across a higher class. Double means square will get. dy by dx in place of that. D square by dx square. Means one more time you have to. Every after doing the derivative, once again, if you do derivative, the value may change. That is called double derivative. Deriving one sum into 2 times, dividing one multiple 2 times, dividing one division 2 times. That is called double derivative. So definitely answer will change. So if the differentiable function derives of is called double derivative. So derivative of f again. Right? So 2 times if you derive, you get the double derivative. So examples are given here. So what is applications? What is the application of derivatives in our physics? So before going for that, let me show you one basic video on the derivatives. Then we'll move to the. Just understand.
The gradient of the line to be the change in y divided by the change in x. And that makes sense for a straight line because actually the change in y divided by the change in x is constant. So if I bring up a little box here on this straight line, we can see that wherever we fix 2 points, if I look at the change in y divided by the change in x to give us the gradient, it's staying at a constant of 2 as the change in y and the change in x vary themselves, but the gradient is 2. It's a straight line. Any point on that line has gradient 2. That's not true for all types of curves. So for example, if I look at this curve here, it's much more complicated. I couldn't just say that the gradient of this curve is a particular number because it's not a straight line. So to deal with this, we drawing a tangent line at a particular point on the curve. So here I'm just taking this point here, and I've drawn in this tangent line. A tangent is just a line for functions that we can write down.
So clear anyway.
Actually, if I wanted the gradient of x cubed, say, at...
It's not so clear for you, not related to us. Anyway, just a minute, it is. So whenever they given the various methods to differentiation, okay. Okay, differentiation, first you have to follow all the 10 rules. You have to identify whether you have to follow constant rule, or whether you have to follow sum rule, or you have to follow multiple rule, or you have to follow the division rule. The 10 rules are there, or double differentiation. So applications are there. See, V is equal to dx by dt is given. This is applicable for rate of change of displacement, which is called the velocity for us. Rate of change of displacement, we use this. So similarly, acceleration A is given. Rate of change of velocity. Rate of change of velocity is called acceleration. So you know x is called displacement. When x is called displacement and y is given for the time. In that case, the rate of change of displacement is written by dx by dt. T is the time here. Displacement by time, what will give? Is nothing but velocity. The second, velocity by time will give acceleration. Right? Like that, there are various applications of derivatives are mentioned here. Applications of derivatives which are helpful in our physics to define a physical quantity. To define a physical quantity. Right? Then partial differentiation also possible. We can differentiate partially also, partial differentiation that will come across generally for the IIT students. It is not so important for you. So, so based on this particular differentiation, we'll have the basic steps are given. Then 10 rules are there. Right? 10 rules of differentiation, very, very important. You have to remember that to solve or to get the differentiation of anyone. Double differentiation will be useful for you higher classes, but some applications of derivatives are very much useful to our physics. All the 7 are there because all related to physics only. The rate of change of charge, the rate of change of flux, the rate of change of velocity, the rate of change of momentum, which is called impulse. Okay, the rate of change of angular momentum, the rate of change of work done. All this comes under the purely for the physics applications. In that there are x cube is there, 3x square you can write. See here, example I tell. What is the differentiation of x cube is given? That is y value is given as. So d by dx of x cube, that is power rule. So power rule, first what should get? We get the 3 here base x, it becomes 3 minus 1 as per the formula. So 3x square, 3x square where it is? Answer. Like that logarithms also rule is given. How to get this? 1 by x. So cosecant square x, cosecant power 4x. So you can, by using that method you have to use tan theta, convert into cos or sine. Right? So like that we can give the derivation for the any physical quantity in physics. Okay, like that there are so many other equation is there. Cos square x is there, is nothing but minus sin square, something will come. So all the derivatives for this, you need to remember the 10 rules. By using the 10 rules, you can solve any type of derivative here, or problem of derivatives. So there are very different types of questions are given. All the solutions are provided for the teachers. So make sure that you attempt, you done all the questions in your notebook and see mathematics. All these questions pattern is purely connected to IIT mains and advanced exams, right? Next, we'll come across integration, another important mathematical part. Mathematical part. Again, integration is very simple part. Again, you have to follow some graph rules. Again, for the rules for integration, like differentiation only. So these all you can see the textbooks only. 18 page number 19, all exam exercise for the differentiation. So you can take help of your mathematics teacher to understand this into depth. So how to find the differentiation of given, right? So these are the chapters which we have discussed in the, then come across our physics, that is vectors. There is a vectors is there in both physics as well as in mathematics also. In mathematics also we use the vectors, in physics also we use the vectors. Why? Because the physical quantities we are saying, fundamental physical quantities and derived physical quantities. All these physical quantities are classified into vectors and scalars, right? The quantity which have only magnitude, no direction, are called a scalar. A quantity which has both magnitude and direction called as vectors. So these vectors have big branch of mathematics called vector algebra. In physics also it plays very important role to find out the direction and magnitude of a given quantity. So in the next class we'll discuss about this, all the vectors and scalars, and in details about the integration. But in meantime, you get the different types of vectors are there. Meantime, you can go through the differentiation part and try to solve few problems from the levels. If you have any doubts, you can clarify with your teachers. They'll provide you the solution. Okay. So that's all for today. So thank you very much, students. Have a wonderful day. These are the topics already covered. Right. So in already covered in the earlier classes about the right. So thank you all of you. Have a wonderful day. Thank you.